Welcome to the Kielder Observatory Podcast. I'm Ian Brannan, and in this month's episode, we catch up with one of our own science communicators, Ishbel Wright, who's been on her own journey north of the Arctic Circle in search of the Aurora.
I would describe it as ghost-like. But the second night we saw it, started again just the same, slow-moving Aurora, and then it went bang. And I screamed.
First, though, we're joined by Director of Astronomy at Kielder Observatory, Dan Pye, for a look at what's going on in the night sky at this part of the year. In towards February, we've got planetary conjunctions. We've also got a sighting of the goddess of love herself as we head towards Valentine's Day. Venus is going to be visible, but you're going to have to be up early, Dan.
Yeah, she's just briefly there. She's kind of peeking out, like, hello, and then off she goes again. So just in the beginning of the month for like a couple of hours in the morning, really early morning, just as the sun is rising, because she's quite close to the sun at the moment. But yeah, you can get that for the first couple of weeks or so. But there is more interesting things to look at. Not that I'm saying Venus isn't interesting. I know we've had this argument before with other planets where I'm just underwhelmed by them. I do love planets. It's just that I don't know, there's more interesting things to see at this time of year.
So taking a glance then towards the skies, as you say, there's still a lot to see. Even though the nights are gradually getting lighter, we've got a way to go before full spring bursts into action yet. So what are we looking at in February?
Being the month of love, there is one gas cloud which is certainly not to be missed. If you have a small telescope, well, I say small telescope, actually this could probably do with a reasonably good telescope. But there is a little cloud of gas that we can look at in the constellation of Cassiopeia. Now, Cassiopeia is the W-shaped constellation. She was Queen Cassiopeia of Ethiopia. And she's actually a really good constellation for pointing out the Andromeda Nebula as well, or the Andromeda Galaxy, sorry, as it's now called. It hasn't been called the Andromeda Nebula since the 1920s, so just a bit out of date there with my terminology. But Cassiopeia is where you'll find a lovely cloud of ionized gas called the Heart Nebula, which is a kind of red colour. It emits a lot of red light and looks like a heart. So there we are. That's nice, isn't it?
Yeah, it's very nice. So look out for that one then. Love in the air, if you can spot that. And it should look like a little bit of a heart. Well, they say you're going to need a fairly decent telescope. What else have we got going on? The Daughters of Atlas are in action, aren't they?
They are, yeah, the Hyades and the Pleiades. I mean, we've seen them for quite a few months now. I love the Pleiades. I think it's a really cool, interesting little kind of cluster. Both of the Hyades and the Pleiades are open clusters, so clusters of stars which are spread quite far apart, as opposed to the globular clusters where you have lots of stars really closely, tightly bound to each other gravitationally. The Pleiades is some stars which formed last in a big cloud of gas, which all of that gas has now dissipated, and you're left with these really big, nice, bright stars. So I've got Pleiades there. Hyades. Actually, I'm going to admit something here. I don't actually know the history of the Hyades, which feels like something that I should know, but maybe I do. It's just not at the forefront of my mind because I don't tend to talk about it as an open cluster that often, to be perfectly honest. But the Hyades is the head of Taurus the Bull. The Pleiades is the heart of Taurus the Bull, often referred to as that. And the Pleiades, actually, I like the Pleiades for its significance across the world, because there's many cultures who almost worship and acknowledge the Pleiades as a returning sign of good things to come. In particular, places like New Zealand have an entire festival dedicated to the Pleiades when it starts to rise again. And if you are a car enthusiast, you'll notice that the Pleiades cluster looks a little bit like the Subaru car logo. And that's because it is the Subaru car logo. In Japan, they call the Pleiades Subaru, which is a word used to, let me see if I can get this right. It's a word used for a collection of people joining together, or groups of people joining together. And so when a few companies joined together to create the car brand Subaru, they came up with this this lovely logo, which was inspired by the Pleiades. So two really nice clusters, dead easy to see, naked eye visible, but best viewed with a pair of binoculars.
Yeah, well, I think with this great knowledge, we can put it in the automotive category, the podcast as well now. So, excellent info. Absolutely. We've also got a planetary conjunction to look forward to as well. Mars, Venus and Neptune. Now, clearly Neptune is not very close to us, so it might be a little bit difficult to see. So what do you think about this planetary conjunction coming up then later in February?
I mean, that's not going to look spectacular at all with with Neptune and Venus. Neptune is only visible with a telescope. Is Neptune, so quite a challenging one to just see with the naked eyes, I think there. But it's always nice to see planetary conjunctions, especially when things get really close, because when you look at them, I sometimes think that you do get a feeling of depth perception. But also what's quite interesting is to just watch it over the course of a couple of days or even hours, where you see conjunctions here in the UK, how different they are just 6 hours later when it starts to get a bit darker in Central America. And you can see these objects starting to drift away from each other. And it just gives you that and reminds you that beyond Earth's atmosphere, all of these other things are moving at various different speeds. And we're just part of this clockwork of movements that happen in our universe. So, yeah, it's a really cool thing to see as a conjunction. But this one, I would say, is less spectacular than some of the conjunctions that we've seen in the past.
Well, of course, but if you do happen to be at Kielder Observatory on those dates when it's happening, then with our telescope, you will be able to see Neptune, all being well as well. And of course, we've got the school holidays approaching rapidly, back end of February, depends where you are as to what week it's happening, of course. But the kids' events are back on the agenda. And tell us what else is coming up and has been going on at Kielder Observatory as well.
Well, we're still we're ploughing. Yesterday, it was snowing. And that was an unexpected thing when we arrived at the observatory. There was big old chunks of snow falling from the sky, and that was mildly exciting, and it looked very pretty. And luckily, it didn't land on the track and disrupt any events, so that was really nice. But battling the weather, as always, as we do at this time of year when it comes to extreme weathers. But it's been nice. We've had some good clear nights. We've had some great other activities that we've been working on recently. We went into Newcastle to work with a group of refugees and trying to engage them in astronomy and astronomical activities. And we've got an ongoing program as part of our Mindsets and Missions funding, which is looking at engaging these in a longer term project. 15 of them into a longer term project. So we'll be doing that in the next few months, and we did that last week, and the feedback from that event was actually really nice. It was really lovely. There was some of our volunteers also went to that event, and they had these connections with some of the refugees that were there, and got to learn a little bit more about their stories and about who they were as people. And I think it really emotionally affected some of the team did this experience, and just seeing the way that they connected with astronomy and hearing about them as people and their experience. And although we're thinking about this ginormous structure that is the universe and thinking about how insignificant we are, also bring it back to a more immediate reality that these are people and they have emotions and feelings and history. And yeah, I think that was a really interesting project for us to be part of, and looking forward to more of that going forward as well.
Yeah, and as we've heard in a previous episode, actually, the night sky means such a different thing for different cultures. You know, it tells stories. There's other meanings behind it that people take from the night sky as well. So dependent on the culture and where you grew up in the world, the night sky, hugely important.
They do, yeah, the tales. And I think this is actually one of the most fascinating things about astronomy. Forget the kind of like, oh, the universe was created billions of years ago from all of these things that are physics related, which can become a mind-boggling mess to get your head around. But the history of astronomy and the inspiration that it's had on society and day-to-day life, I think is absolutely incredible. When you look back at things such as cave paintings on walls from 35,000 years ago. 35,000 years ago, humans were looking up at the night sky and thinking, yeah, this is a significant thing. I'm going to paint it on a wall and make a story out of it. It looks like something I'm familiar with. And therefore we get these interesting shapes that then later become constellations, and then people who developed this as part of their spiritual belief and still do, in fact. I mean, astrology is such a faux pas in astronomy. We always kind of shrug it off and go, astrology, make-believe. But actually, it's somebody's belief. People believe this stuff. And if that inspires them to find out more about the universe and just acknowledge this incredible theatre that happens around our planet, then I don't care. I think it's a great story, and there's many other stories just like it across the rest of the planet that still are practiced as well, as we just briefly mentioned there, celebrating the rising of the Pleiades and stuff like that. It is significant in culture still today.
And if you'd like to hear more about that topic, then we had a guest called Jarita Holbrook, who was with us a little while back. If you scroll back through the previous episodes, and she talks all about this topic of the night sky and the meaning of astronomy in different cultures. Right now, then, to round off your segment, Dan, can you give us your pie in the sky? A little challenge for the month of February for all astronomers, but maybe you need some binoculars or a telescope to spot this, but a little bit of a challenge.
Very appropriate one for the month of February. Again, drawing on that romantic theme. There's a great cluster called Caroline Rose Cluster in Cassiopeia again. So back to Cassiopeia, the W-shaped constellation. In there, you've got a cluster of stars, which is supposed to represent what looks like a rose. So we call it Caroline Rose Cluster. It was actually discovered by Caroline Herschel as well. And it's a beautiful cluster. It does look like a globular cluster, and I don't think it is a proper globular cluster. It's just a very populated cluster of stars. But there's some looping stars and some dark shadows that kind of swirl throughout it, and they make it look a little bit like rose petals. So a nice thing to look at with a good telescope, I think, with this one. But if you don't have a telescope, just Google it. Have a look at the picture, because it is a really beautiful little cluster. Loads of different coloured stars and stuff. Really nice.
Let us know how you get on. And, of course, if you manage to take some pictures of it, then share those with us as well. We'd love to see them. And Dan will be back next month on the Kielder Observatory Podcast. For the rest of the Kielder Observatory Podcast this month, the topic will be the Aurora Borealis, the Northern Lights, and searching for them. Now, our Aurora nights are always very popular indeed. Now, there's obviously never a guarantee that you will see the Aurora, unfortunately, on our Aurora nights, but it does occasionally happen, and hopefully what we do in those sessions, if you don't see the Aurora, is give you all the information that you need to go out Aurora hunting yourself at another time. Now, one of our science communicators is a particular expert when it comes to the Aurora Borealis, so much so it's very much the centre of her studies away from Kielder Observatory. Ishbel Wright is one of our science communicators, and over the course of the new year, she actually went over to Norway, travelled north of the Arctic Circle, up to Tromso to get involved in some scientific work, but of course that largely involved tracking the Aurora Borealis, and she's here to tell us about her adventures and also give you some information in a little while as well about how you can maximise your chances of finding the Aurora as well. But the interesting thing is that this journey all started for you, Ishbel, at Kielder. You were working, doing your job as a science communicator, and that's where you fell in love with the Aurora, because you saw it on an Aurora night as well.
I was working, it was actually a month and 2 days in, and I've been hunting the Aurora at university just being like, oh, it'd be really cool to see it, because I was up in Scotland, so you can sometimes see it quite well there. And then one night it just started to appear on the horizon, and it was on an Aurora night, which was quite fun. Right at the end, some guests had started to leave, so we had to send people up the track running to grab them back down. But it was just these big, bright pillars appearing on the horizon. They looked really like, is it not, is it? And then they started to like glow and shine, and it was quite iridescent. And then they sort of dynamically move side to side, and it was like Fantasia. And I was just sort of in awe, and I was like, I can't believe it. I can't believe that's really there. And I wanted to know how and why exactly. And then the more I read about it, the more I was like, I need someone else to explain this to me. Just kind of snowballed from there, just reaching one little Google search, and my life was changed forever. So there you go.
So you're very deep into it now then. So what have you further learnt about the Aurora that you never realised? What's like the wonder for you with it now that you know as a result of studying it further?
I don't know a huge amount yet because it's only been a couple of months, and so I'm still in the preliminary research stage to define exactly what the project will be. But I've learned that we don't know a lot, which is quite fun. Every time I assume we have an answer on something, always in most branches of astrophysics, it turns out we don't actually know. But with the Aurora, I think one of the things is the ionosphere is something I didn't really know an awful lot about, but that's where the Aurora occurs. It's this level about 50 to 100 kilometers up in the atmosphere. And that is what's called the ionosphere because it's full of ions, which are charged particles, because it gets hit by the rays from the sun and they get excited and they chuck out all their electrons, so there's lots of charged particles sitting up there. But that, it's not actually to do with the Aurora, but that is where we bounce radio signals off to get GPS. So
on the upside, if you don't see the Aurora, at least you've got a map in your car.
Exactly. So we do a lot of radio astronomy for Aurora. You send radars up and then you can work out what the density and the temperature is and stuff like that, depending on how high up it can get. But it's also really interesting, and also one of the reasons why Aurora study is really important, because Aurora study is the fact that we have extreme amounts of energy in the ionosphere, which is where we bounce off all of our radio signals for GPS. It's also where we're sticking a lot of our satellites, which totally don't have all of our security and internet and communications and banking now involved. All of our navigation. I learned if the magnetic field switch, the trains will go backwards.
Oh, which could be a good thing, depending. But
don't ask me how to explain that one. I know we might get some on time. It'll be great. But yeah, I learned there's a whole host of things that it's important with, and obviously because air can conduct not very well, but if we get a really huge storm, which is very rare, has not happened since like the 1800s, it can get down to the ground, and it's not like we have a national grid, do we, of electricity that powers everything.
So with that in mind, though, because we haven't had a major solar event that's affected us in an electromagnetic sense on Earth for a very long time, does that mean that maybe we're due one?
Statistically, there's always that, it's not happened for a while, so it has to come soon again. But I think one of the reasons we're not too worried about a massive one is because we don't know why the last massive one really happened. And the sun is a very stable thing, because it's all caused by the sun. Basically, the sun burps and throws a whole bunch of stuff out, and then it interacts with our magnetic field and our atmosphere. And the sun doesn't have a lot of gastronomical issues. It's a very stable middle life star, so it's not doing many extreme things, which is why we couldn't exist and live here and thrive quite nicely without the sun being weird. So I don't think we have to worry too much. We just have to worry about what we keep putting up there. It's more the amount we rely on it and the more technology we put up there and depend upon. Then the little things that the sun does can become a bit more effective. But the sun actually having, a really burpy time, it's not going to be too bad, I don't think. Come back in 5 years when I'm finished. I may have an entirely different story.
I think that's the greatest description I think you could ever have of what the aurora is and what causes it. And it's a sun burp, but at least the sun doesn't have gastronomical issues. So we can rest assured on that one. Ishbel, tell us about your journey then north of the Arctic Circle. You went up towards Tromso. It's a fair way to go. Tell us about getting there.
Yeah, it was the Arctic Circle. So it was not a great journey. It's the first time I travelled alone by myself ever, because I've always gone places with my family or with my friends, but I've never done a solo trip. And because I was going with the people from Southampton, I was the only Northumbria representative. They were all flying from London, obviously, and I was not flying from Newcastle down to London to go we go to Oslo first and then up to Tromso. So I actually flew from Edinburgh, which is much cheaper to do, everyone. Flying from Newcastle, you have to do like 5 stopovers in Europe before you get there. Edinburgh, almost direct. It was great. So I went from Edinburgh, and I was terrified that the plane wasn't going to be there, that they didn't have my bags checked in, that, my passport was out of date, all this stuff that, the nervous flyer stuff. But it was absolutely fine. Got through security, got there, got to Oslo, easy. I was like, oh, phew, fantastic, simples. Then got on the plane from Oslo to Tromso, and halfway there, the plane got diverted because Tromso airport closed while we were midair. So we got relocated to Bardufoss for a couple of hours. Didn't really know whether they were going to put us on a coach and send us on, but the plane we were on was heading up to Alta, which is even higher up. So half of the guests, the passengers, were getting off, meant to be getting off in Tromso, and then the plane was meant to continue on. So the plane dumped us off in Bardufoss and then left us. And we had to wait for another plane to come and rescue us and take us up to Tromso. So that was fun, and it was a snowstorm, so there was this big snowy world going on around us, and I didn't realize they did this for planes, but they have this big hose system. It's basically a massive kettle. When you're told not to pour like a hot kettle over your car to defrost it, they just have a massive one of those to defrost the planes. So I was looking out the window, this big, long-reaching, like giraffe-like structure appeared, and then just hosed down on the plane, and all the steam went everywhere. And I was like, "What's happening?" But it was all fine, and we got there eventually. So I was meant to arrive at 7 in the evening, but I didn't get there until 10 past 11. Which was fine though, because then I lined up with the others who had also gotten stuck in Oslo, and then we all got a taxi to the hotels. And because there was 5 of us, and we were renting a car, and we had to get all the stuff, so we were in Tromso, but we were actually staying in a place called Norskebuten, because the observatory we were working at was Skebuten Observatory, which is about an hour or so from Tromso. They had to transport all the stuff over, and so I volunteered as tribute to not help out with that, have a lie-in and do some touristy stuff around Tromso for the day, which, was a great sacrifice. But I did enjoy not having to then get up at like 8 o'clock in the morning to get started with moving everything back over to the observatory. So it worked all out in the end. But Arctic Circle travel is sometimes dubious because it does snow a lot and planes don't do that.
Yeah, snow, ice and planes are usually not a good mix. Tell us about when you got there then. You're north of the Arctic Circle. At that time of year, the sun doesn't really come up, does it? So it's sort of darkness or twilight all day long. What was that like?
Magical. It was gorgeous, but the sun did not come above the horizon until the 4th day we were there. 3rd or 4th day? Yeah. So like the sun was not above the horizon at all. And so it felt like I thought it was going to be a lot darker than it was, but actually the sun is just skirting the horizon, so you get a lot of astronomical twilight, and because everything's covered in snow, especially because it was fresh powder, it's quite reflective. So it was quite light for the hours that it was light, and that was only about 4, but we've just had winter here, so we're used to only about 4 hours of daylight, so it's kind of like just going back to the middle of winter for a bit. And the sky was just a little bit less bright. Didn't see the disk of the sun until I returned to Scotland, which isn't where people usually see the disk of the sun. But I really wanted to go catch it on the day it rose, because that was the first time it was above the horizon for 3 months or something in the Arctic Circle, but we saw it just shining on one of the peaks of the mountains, because it's a very mountainous country, so you're always in a valley, so it's quite hard to actually get to a horizon line. But we saw it come just above and touch one of the top of the mountains, and it was really beautiful. It was like really bright orange phoenix rising from the ashes. You can see snow coming off the top of the mountain. It was really cool. But yeah, we wanted it to be dark for a lot of the time we were there anyway, because we wanted to, align the cameras to the stars and actually see the aurora. So it was a good job it got dark early. We just sort of lived with red torches an awful lot, which, working at the observatory, I was very used to.
And Kielder was very much represented on your trip to Tromso, because you took your Kielder Observatory mug with you as well.
Famous mug, taken all around the world as far as Whitley Bay and now the Arctic Circle. Recycled and printed in Northumbria. So if anyone wants to visit, it's one of our number one souvenirs that people get. And if we can get started again on the social media challenge of see how far you can take the mug.
And how was it then when you did finally see the aurora and it made this appearance and you saw it in all its glory to an extent you've never seen before? What was Arctic Circle aurora like for you?
Do you want me to play a clip of me screaming when we saw it?
If you've got it, yes. You're clearly very excited about it. People obviously can't see that if they're listening to this as the podcast, but to sort of describe it, it looks like green clouds. It looks absolutely amazing, unlike any aurora I've seen photographed or videoed in this country. So tell us about it, because it looks unique.
The first night we saw it, I didn't realise it was what it was, even though I've been telling people for the last year how to go find this thing. Even I still was like, is it? But the first night, so I only saw it 2 nights. We were there out of 5 because it was cloudy. Even in Norway, you get thwarted by clouds occasionally. But it was just this big band of light started to slowly glow above us, all the way from the east to the west. The whole sky, not the whole sky, but the strip across the sky, east to west, started in the north, and it started to move slowly south. And I was like, that's a weird cloud. Hang on, I don't think that's a cloud. And then got my trusty phone out, took a photo, and was like, oh, that's green. And then started to wait a little bit, watched it, and you did start to see it a lot better with eye, because if you're out dark a lot more, and you just saw this moving slowly southward right above my head. In Kielder, I'm just used to seeing it on the horizon, and that's about it. Here it was going right above, moving on, and then it started to get brighter and brighter. It started to turn a little bit green that night, but it wasn't huge. Aurora has sort of 3 phases it works through, where it's got the, I don't want to get this in the wrong order, but it's the growth, the expansion, and then the recovery phase. So I saw the growth phase that night, where it was slowly getting bigger and brighter, and then it's meant to have a substorm, which can either take like 4 minutes or 20 minutes. And unfortunately that night the clouds did come, but it was there, it was right above us. I even started to see some pinky hues. Because it's not opaque, it's transparent. I would describe it as ghost-like. But the second night we saw it, started again just the same, slow moving aurora, and then it went bang, and I screamed. And the others were inside working on the camera, because obviously we were actually there to do some work, but I designated myself aurora hunter for that night. And I had just started banging on the door screen, get out, it's doing it. And it just lit up and started moving, on nanosecond timescales. It was so dynamic. These ripples were going right across the sky, the swirls, the twirls, the bands were splitting right above me. And we had these 2 big streams going right across, and both of them were moving and shifting, and it was just absolutely incredible. I could not go inside for 3 hours. Like, it lasted for 3 hours. Sometimes they can last for like 40 minutes or a couple of hours, or maybe even only 20 minutes, I think. But this lasted for like a good 3 hours. It was just going for it. And I got a cold because I could not go inside. I did just lie in the snow for a good long time. And we all took lots of photos. I experimented a lot with trying to take different types of photos for 10-second exposure was too long. It all went blurry. Even 3 second, I couldn't quite get it to be sharp. To eye, it was crystal clear, sharp structure. In most of the photos, it's kind of just this wibbly band thing. But it was sharp peaks and just, it was absolutely incredible. And the green was really green, but I would say minty ghost. That's how I would describe it. It was a minty ghost. Because it's still transparent, obviously. So a minty ghost is how I describe it. It's not the big neon greens that you sort of see in photos. It was minty ghost. You did get purple hues as well. Green, not green, we know about the green. Purple and pink hues as well. Bits of white in there as well. Just from different light signals that your eyes don't always catch what the colour is, because our eyes aren't very sensitive to light. So you need a lot of signal for us to pick up on anything. So that's why you can get sometimes whites in there. Why it first appears white, and then if you've got enough, you'll get the greens, and the pinks and the purples come from nitrogen, which is not as abundant as oxygen. Oxygen's where we get the green from. So if we had different type of air, we'd have different kind of aurora. But it was awe-inspiring, and the leader of the campaign, Dr. Dan Whiter, he has lived in Finland for 4 years and has been studying the aurora since his PhD, and he said it's the best one he's seen in 10 years. So I felt pretty cool to say that's what I saw. I even was able to FaceTime my husband's family group chat while they were having their Monday night meeting, and I called into the WhatsApp and they could see it on my phone.
Wow, amazing experience. And obviously when we see people take photos of the aurora, sometimes they look a lot more intense in photographs than they are to the naked eye. So how did this look to your eye versus the pictures that you got?
Yeah, the colours were sort of neon deep forest green, whereas by eye it was a bit more minty ghosty. But we had a variety of it was all we had were camera phones. No one brought a big camera, but so you could see on everyone's phone a different type of colour saturation that was achieved. So you could go, yes, this is all the same aurora, but there's different colours in there. So I've got an article to write for the Kielder newsletter about that. But it's still really cool because it still captures how gorgeous and dramatic it was, in terms of feeling, maybe not in terms of true eyesight. But the thing is, you take these photos and then you have phenomenal photos. Why would you not want to post that to social media? So you get how you can get a lot of this sort of unrealistic expectations start to form of people, because if you take the photo, you really love it, you want to post it, and you then always tag it with, this was amazing, it was phenomenal, one of the best experiences of my life. And you always forget to put the disclaimer, it wasn't the best. This is not realistic out of what exactly I saw. So you can get how it can start to, with the dawn of social media, well, not the dawn, but the eruption and continuation, the middle life of social media now. I
guess it depends when you were born, really, doesn't it? Because some people have grown up knowing nothing else.
Yeah, so with how prominent that is now, you can start to definitely see how it can snowball. And if you don't live somewhere where you could see it, not many people do. I mean, Tromso itself is the third largest city in the Arctic Circle, to the other two being in Russia, and there's not a lot of people there, so it's not somewhere that you can commonly catch it, because the Arctic Circle's not where a lot of people live. I would love to live there. I'm 100% going to move. That's my dream now, is just to live in the Arctic Circle. It wasn't cold. It was cold, but it was this dry kind of cold. It wasn't this soggy, damp, seeps into your skin British cold. It was just, as long as I wear all 25 layers and some good thick boots.
Yeah, it's definitely not the place for sliders and shorts, that's for sure. And tell us about the work you were actually doing there, because you're enjoying the aurora, but as you mentioned, you were there to do some work as part of your university studies. So what was it that you were there doing up in Tromso?
Yeah, so the whole experience was this campaign to go set up these cameras. They are a update on the ASK cameras, which are up in Svalbard. These cameras, there's 4 of them instead of 3, and we called them Embla because that is the first woman of Greek mythology, and it's my first time with the lovely astronomical don't know whether it's a rite of passage where people have picked a name and now we have to shove words into it to make it fit. At the moment, the best we could come up with was excellent measurements of bloody lovely Aurora. It's our current acronym for it. I don't know if we're allowed to use that. Beautifully lovely Aurora, yeah. So that might be it, or it might be something like electromagnetic multi-band light analysis. It doesn't work very well, to be honest. We might not have one in the end. But it's 4 cameras that are observing at different wavelengths to capture a tiny part of the sky, absolutely tiny. It's like fisheye lens, but it's like a 8-degree field of view. It's very small, but hopefully it's to catch the fine structure of the aurora in extreme resolution. And from that, you can then pull out whole hosts of graphs and data to try and analyze what's actually going on there in the magnetic and electric fields, and try and then explain what's happening there with physics that we know, and try and work out what the fine scale is happening. And so it's a really cool project. It's now set up in Skibuten instead of up in Svalbard, so less chance of polar bears. But it's also near the SCAT 3D site, which is a massive radar system, absolutely huge radar system. So you can combine, like I said earlier, with radars. We can bounce off the ionosphere, which is where the aurora occur. So we can do a whole bunch of combinations of things. So it's not just our camera that's going to look at cool stuff. It's our camera's going to look at cool stuff, and then we're going to combine it with all the other cameras in the area and hopefully get the full picture. That's the plan anyway, as long as we catch the aurora in it. So I think we've picked a good spot, considering we saw it twice while we were there, which is really nice. But the building and setting up of it was a lot more haphazard than I thought it was going to be. I thought we'd have this proper manual of instructions and exact measurements of what we needed. But no, we had a building that's got a dome in the top of it, and we got a whole bunch of wood. We built a structure. We then took down the structure because we didn't measure it right, sawed a little bit off the ends, stuck it back in again, put the cameras up in the dome, and then built some shelves in, organised the room to make it sort of tidy and neat, because it kind of just had a whole bunch of stuff in it, and then set up all the cameras. And the main thing I think I learned was cable management. We printed over 75 labels. The label maker was working harder than the rest of us, and every single wire has got a label on it. We know where it's going. Everything's been cable tied in the right places, so that in the future, if anything breaks, we can hopefully fix it a lot quicker, because that's something they've learned in the past, that all these wires eventually cause problems later down the line when just one thing breaks, but you need to take the whole thing apart to fix it. So hopefully it won't break. Hopefully once it's fully set up and finished, that'll be it, and it'll be sorted for a good wee while. But yeah, it was just there was a lot of woodwork and sawing and hammering and drilling, which was really fun. And I have a lot more of a get up and go attitude now, I think, towards doing things, because beforehand I would definitely need, a set book of instructions and all the measurements pre-done and everything worked out before I'd even consider any form of DIY task. And now for a very expensive, fancy camera system, we kind of just got some wood from the local DIY store, and voila, massive frame has now been built.
Sounds like the world's most glorious DIY astronomy experience, if you can combine the two. And just to give a bit of advice for people that might be looking for the aurora as we get towards the next equinox, as the spring season begins, there is a chance of seeing it again increasingly in the UK. How can people improve their chances of seeing the aurora? What would be your advice?
So I think the first thing to do is you manage your expectations. You're not going to probably see it overhead swirling and twirling. You're probably going to see a little bit of green on the horizon, maybe a band, maybe it looks arc-like, you might have some spikes coming out of it. And it will probably be white, not green. You might get a little bit of green on the horizon, but your spikes are probably going to be white to the eye. The other thing is make sure you get somewhere dark. So the sea is always a great place. Go to the coast because there's no light pollution when you look towards north over the sea. If you go somewhere like the Pennines, lovely dark area, but you have to hike a hill to get to see the horizon. And if it's only going to last for 20 minutes, or like you see it and then you need to get there, you know, you've probably like used like maybe 40, 50 minutes to get there. Might be only going on for a little bit longer. Now you need to hike a hill first? No, I don't want to do that. I mean, I love hiking, but maybe not, you know, in the dark. And the other thing is you don't want a big city such as Carlisle or the Borders to have that big light bubble, because you can see that in a really dark area. You can see the light domes. We can see the light dome from Newcastle up at Kielder. So if you've got a big city, you'll have that in the way, and that will, because our eyes are so poor, we have to give them the best possible environment to see it. And if you've got a light dome, your eye is going to go, haha, that's something, and it's going to saturate your eyes and you're not going to be able to see the proper aurora. So getting dark, getting somewhere with obviously where you can see the northern horizon, quite helpful. Don't go south. And then the last thing is to go when you hopefully know it's going to be there. So there's a whole host of apps that you can use. So there's such things as like Aurora Alert, and there's Glendale Skies. These are some really good apps that have sort of ping alerts to say, hey, there's some stuff going on, and there's a whole bunch of numbers in there. If you come to one of our talks, we explain some of the numbers to make it a little bit easier for you to understand. But one of the main things I always recommend is join a Facebook group or a Twitter or an Instagram group, because if someone sees it, they are going to want to let people know. And so the best thing you can do is if it pops up in your Facebook going, someone in Whitley Bay has posted a photo of the aurora 5 minutes ago. That's usually one of the best ways to know that it's going on. That's how I've done it here in the UK. In fact, the one night I missed it when it was above my village in Wall. I missed it because I had decided to have a digital detox night. So there you go. Turns out I was really annoyed because people had photos of it like above my house, and I did not catch it. So that was really annoying. The other thing is definitely do bring a camera or a phone, because that's a really good tool to make sure it is there, and then you can convince yourself with your eyes, that's what it is, there it is, and then you can wait and see if it's going to get bigger or not, or you can at least say you saw it a little bit. But you can't, if you're not sure, you'd think you're just looking at a cloud. A camera is a great way to confirm its presence, which is great. But yeah, one of the other really cool things that I've actually discovered up in Norway is that in Norway they do have all-sky cameras that you can have access to online. So you're just going to search Aurora cameras, Arctic Circle or Norway, and you can find people who have got these cameras set up. And if the aurora's in that camera, then obviously the aurora is happening. You might even be able to see it from here. But that's how we did it. We looked at the camera like, it's there! Get outside! But that's because the camera was right next to us in the same building. So that was quite useful. I'm going to try and set one up at Kielder, I think, and see if we can catch stuff. That's an aim of mine, is to try and set something up at Kielder so that we can have something there.
Yeah, that would be amazing to have a live webcam that people can log on to see the aurora at Kielder when indeed, of course, it does make a showing. Well, look, thanks a lot, Ishbel, for telling us about your story, and happy aurora hunting when the sun next has a burp.
Yeah, fingers crossed. No clouds.
Thanks for listening to this episode of the Kielder Observatory Podcast. And don't forget, you can keep up to date with everything that's happening at Kielder Observatory online. KielderObservatory.org is the website, and that's got all the information of what to look out for over the course of the coming month. And of course, your chance to book your tickets as well to come and visit us one evening. There's plenty on sale, loads of different themes for the different evenings as well. So pick something that is up your street. But certainly, we do have a few Aurora events taking place over the coming months. So look at those if you want to find out more about the Aurora, and maybe meet Ishbel and Dan, who appeared in this podcast at the start as well, in person. person and come and see us for an evening up at Kielder Observatory. Don't forget to check out some of our previous episodes as well. There's plenty to go through, and we'll see you on the next episode of the Kielder Observatory Podcast.